Hello, my name's Matt, and today we're going to be talking about C++ package managers again. I have always been a massive fan of C++ package managers like Conan and Vcpkg. I think they truly save you a lot of time, as well as making your build system a lot more flexible when porting your code to different hardware or different systems in general. Up until now, I was relatively unaware of any C++ package managers written entirely in CMake that could seamlessly plug into the build system. At least I didn't know any good alternatives to Conan or Vcpkg that can model the build of your third-party dependencies quite well. Has my opinion changed? Is CPM a good candidate for these more popular and stable package managers? We'll discuss all of this in this video, so stay tuned. First of all, what is CPM? So CPM is an open source project, as you can see here, it's on GitHub, that provides a package manager for C++ entirely written in CMake. CPM is a wrapper around the CMake fetch content module, which allows CMake projects to pull third-party dependencies and build their CMake as part of, the main project. But let's talk about the drawbacks of fetch content for a little bit. So fetch content is really good for simple use cases. So when you want to pull someone else's CMake project and build it. Aside from that, fetch content is far from a package manager. It doesn't handle isolation of dependency builds or caching between projects very well. On top of this, it's difficult to get a trace of all the third-party dependencies and their versions used to build your project, i.e. a lock file as it's commonly referred in other languages package managers. And this is where CPM comes in. It expands on the fetch content functionality to cache project downloads between projects, versioning checks between transient dependencies, better offline builds, package locking so you can manage transient dependencies better and get that lock file. All of this with a fairly straightforward API, as you'll be able to see in just a second. Before we continue doing anything else, I would just like to ask you guys to please subscribe to the channel and like the video. It does help me out quite a lot, especially when hitting that 3,000 subscribers target by the end of the year. So thank you very much. So let's take a look at what CPM usage actually feels like. So obviously there are quite a few examples and I got most of my knowledge from the GitHub README as well as their documentation and source code. But I'm going to be condensing all of this down and then showing you guys how to use it. So I've got a very basic CMake project, which is just declaring a executable and a library within CMake. So I'm not going to explain how all of this works, but if you are interested in knowing more about how CMake works and how you can create a very basic project, you can check out this video up here. But essentially what we have here is an executable and a library. And we also have this file called dependencies.cmake where I include it into my main CMake lists, right? So this is where all the CPM stuff is. If we take a look at that file, you can see here that I've got a file download call in CMake that will download the CPM.cmake file and have an expected hash in it. So this is how you guys can download the CPM.cmake file directly from the CPM's Git repository. You can find this exact same snippet of code on the CPM Git repository's README. However, do bear in mind that whatever is there is kind of out of date, it seems. So I'm downloading the latest version here that I could find. The only thing that you might have to change if you do change the version is also changing the expect SHA-256 here. You can do something like that with SHA-256 sum on terminal, and on Windows, I don't really know. You're going to have to figure that out yourself. But once you've included this file download call here, you'll be able to see that the CPM.cmake file will be downloaded to the build directory because that's what we provided in the download call here. So you can see that we have under build and then my Clang debug ninja directory, which is my build directory. There is CMake and then CPM.cmake, which is, that file that we downloaded. And this is all you need to actually be able to start using CPM in your project. Because of this include call here on line 8, we also make sure that we include that file once it's downloaded, which means we can make calls to the CPMAddPckage function and start including all of the third-party dependencies that you want. As you can see, I already have some calls to CPMAddPckage here. And this is the function you're going to be calling all the time. This is the function that adds a third-party library. And we'll go through the arguments that it has in a second. But I just want you guys to see what you can do here. So you can pass in the name of it. I don't really see what the name is used for, except maybe for identification reasons inside the CPM source code. You can also provide the GitHub repository here, which in my case is raysan5raylib. The git tag, which is obviously the tag that will be pulled, and version here, which is the same as the git tag. But in my case, I can just delete the version argument here, and the version will be implicitly acquired from the git tag, as far as I know. And the same thing for Google test here. The only difference is that we have the options, which is basically the flags that will be passed to the build of Google test. So this is how you pass it. You can pass options down, which is very interesting. And I've also got FMT here in two different flavors. So you can see that I have FMT firstly declared with the verbose function, or if you want to use CPM in the same kind of way as Conan or Vcpkg, you can also pass a single argument with a string to it. CPM does support just one argument strings where you have to provide where the project's coming from, the path to the repo here, and then the version. Now, there are some interesting stuff at the end here. So for example, I am adding a library gtest, which is an alias to gtest. And why am I doing this? So as I said, CPM doesn't actually provide recipe files for gtest to build here with CMake, right? So all this is doing is actually just grabbing the project, caching it somewhere, and doing some nice versioning stuff. Because it's only doing that, all of the targets defined in the Google Test project aren't going to be namespace. They're going to be the same names as what Google Test does, right? So just bear in mind that you might have to do some manual work. This is possibly the easiest case of manual work that you may have here. You might have to do more complicated stuff to make some of these targets build, but just be aware. But after all, that is just as easy as linking the targets that you pulled with CPM into your CMake targets. So in my case here, I have the executable target where I am linking FMT against it. And FMT has been brought in with CPMAddPckage. There isn't anything else to talk about in terms of the usage of CPM. Is basically just as straightforward as you can see. But perhaps we can talk about the particular arguments that you can pass into CPMAddPckage here. So I've actually summarized the arguments as I could see in the source code here and tried to make some sense out of it so you don't have to go through it. But because CPM seems to lack the documentation here for exactly what you can put into the CPMAddPckage, what I actually did is I went to the cpm.cmake file, as you can see here, and searched for the CPMAddPckage function. And I basically digested what this does for you in CMake and then tried to make sense out of the arguments that you're passing into it, right? So here it is. So the name is the name of the package, and this gets passed down to the fetch content. If you remember, using fetch content and fetch content declare, you have to provide a unique name for the package. This is the argument in here. I didn't quite get force, if I'm honest. Version is the version string of the package that you're pulling. And this is actually implicitly acquired from the git tag if you pass it. So you may not necessarily have to pass version all the time, but do pass git tag if you're pulling projects from GitHub or GitLab or anything else. The download will only download the package and not build it as part of your CMake. You will not call add subdirectory on the package. And this may be good for when you just want to download the library itself, but you want to kind of manually provide the integration of that package in your project. GitHub repository is fairly self-explanatory. You just pass in your GitHub repository. For example, I have a library under my GitHub called base64pp. And if I wanted to include that with CPM, I would do it like this here. This is what I'll pass into it. GitLab repository is the same as the GitHub repository. Bitbook repository, more of the same as well. Source directory, I wasn't sure as well, but I believe it's where the source directory will be located for the package or where it will be downloaded to. Find package arguments are the extra find package arguments. So the no cache argument will make sure that the package is not being used from your cache. The system argument will essentially cause the system property to be set in all of the targets in that project. It only really works in CMake 3.25 because it relies on the CMake's add subdirectories system property. Git shallow will mean that your third-party package will only shallowly be downloaded on Git. So if you have a project with a lot of history, you maybe want to set this on because it'll be faster. Exclude from all will exclude all of the targets in the third-party project to be built by default. And then there's also source sub dir and custom cache key, which I'm not going to bother to explain because I don't really see how this is going to be useful for beginners. Now let's talk a little bit about CPM's caching functionality here. So CPM does support source caching, which means you can cache your downloads. It doesn't really do build caching, but if you want to actually make sure that you don't download the dependencies every time you include it in different projects, you can set this variable here, this environment variable, that will dictate where CPM will download all the source file to. So in my case, I've already got this on my bash.rc or my bash.rc equivalent, which is Edge-Shell. And I recommend doing the same. So I'll just show you what I have here. And you can see here on line 150, this is probably what you have to add in the bash.rc as well. And if you've used CPM when the CPM source cache variable is set, you can see that it downloads all of the source files into that directory. So let's take a look at it. As you can see, I've got 3 dependencies here, and all the source file for all of them are inside there. There isn't much more to this cache. I would recommend setting it so you don't have to re-download everything all the time. And especially if you start a new project, but you don't have internet, but you have the source code of a dependency already in your machine. And that means that you won't have to have the internet connection to download a dependency and things will just build, hopefully. And that's pretty much it for caching with CPM. It's actually a very basic system. Now, let's talk about the differences between, something like CPM and a more mature package manager like Conan or Vcpkg, because they kind of both work in the same way. So in Conan, when you include a third-party package like OpenGL or zlib or anything else for the matter, Conan will obviously download the source code from the internet or the package and then build it on your machine and kind of store it somewhere in your machine so you can use it in different projects. But what does that actually look like internally? So first of all, when you declare a dependency in Conan, such as an OpenGL dependency, Conan will actually gather all of the settings that you're using to build a dependency, and that includes things like compiler, compiler version, build type, build flags, C++ standard, and OS settings. It will model that build configuration and keep it internally. It will then download the package or the source code for example, FMT or OpenGL or whatever it is that you're including. It will build the package with the settings that we have configured and stored internally in Conan in here. So once Conan builds your third-party dependency, it will actually store everything inside a hashed directory, a directory with a hash on it. And the hash is essentially the hash of your configurations that was modeled in Conan. And that's how Conan knows whether or not it can use the same build cache on other projects. So for example, if I include the FMT library in two different projects, but they are both building FMT with the same settings, with the same OS, then there's a very high chance that you won't have to build FMT again because you will just pull it from the cache. Now, CPM is just a wrapper on the fetch content module in CMake, so it doesn't really do build caching as you can see here in Conan or Vcpkg. Basically, what we have is just some sort of extra download caching on top of fetch content. So we don't get most of this stuff here, but this does mean that CPM doesn't really require any recipe files like Conan and Vcpkg do to make that package build in whatever package manager it is, because it's simply a thin wrapper around fetch content. But unfortunately, that does also mean that you get less isolated builds. So for example, your project's build flags and build settings will probably cascade down to your dependencies, which may or may not give you some issues, which means you have to apply patches by yourself. But in that way, it's much simpler than the Conan and the Vcpkg model here for the build. Now, if you are interested in learning how Conan works or Vcpkg works, please check out the links in the description. There will be a link up here as well to my Conan video, and that will explain to you in more detail how these third-party package managers actually work. Now, here is the golden question. When should you use CPM versus when should you use Conan or Vcpkg? In my honest opinion, I think that if you have an open source project on GitHub or GitLab or wherever it is, and all the third-party dependencies that you're using are also open source and also available on one of those Git websites, then I highly recommend using CPM. It simply just means that your user is not going to have Conan installed or Vcpkg installed to be able to build a project. Now, we have to be honest and also say that CPM is kind of lacking in features compared to Conan and Vcpkg. And more specifically, I am talking about build caches and the whole build model in general. It doesn't really do build isolation of your third-party dependencies. So for example, if you wanted to build them with different flags compared to your project, or if you wanted to also cache builds between projects, you won't be able to get that with CPM. On top of all of that, it only really works with open source libraries. So this is meant to be used with libraries where you have the source code, where you can build it with CMake. For anything else, so for example, if you have a pre-built library, you will not be able to wrap that pre-built library with CPM unless you write some custom CMake for it. And with Conan and Vcpkg, I think that's actually quite easy. So there it is. That is my opinion. If you have a very simple open source project and all your third-party dependencies are also open source, use CPM. If you have anything more complicated, maybe you have a closed source project that depends on closed source dependencies that are pre-built, or simply if you want to make use of build caches, use Vcpkg and use Conan. And finally, if you guys enjoyed this video, I would like to ask you to please subscribe to the channel and like the video because it helps me out quite a lot. And I'll see you guys next time, and bye-bye.